All right, so there we go. So here is 7.3, question number 1. So basically we're going to do exactly what we did Tuesday, but now it's word problems. It's real life linear programming. So we learned how to solve them Tuesday. Now we're going to set them up and then solve them. So here we go. A chainsaw requires 3 hours of assembly and a wood chipper 5 hours, like for the factory to assemble. A maximum of 45 hours of assembly time is available in the factory. The profit is $150 on a chainsaw, $220 on a chipper. How many of each should be assembled for maximum profit? So very, very much a real life question, huh? This is linear program is nice in that you see some very real life situations. This is something that companies would really much want to know. This is the kind of numbers they would have. They know how long it takes their factory to assemble the chainsaw is 3 hours, the people that work there. 5 hours, the chipper's a little bigger, it takes 5 hours. They have 45 hours, a certain crew has 45 hours to give to working on assembling these things. So what would be the best plan? What should you have your crew do? The profit is $150 on the chainsaws and $220 on the chippers. Should they spend more time on the chippers? Because the chippers make more profit, but they also take more hours to assemble. Therefore, should they spend more time on the chainsaws? Because they can crank those out with less assembly, but they make less profit. So where's the best solution? Because you see there's two forces working against each other, like real life, huh? Basically, more time for the chippers, but there's more profit, so you want to do more of them, but it takes more of your time, and less time for the chainsaws, but there's less profit. So we want to find what's the best answer. How many chippers and how many chainsaws should the crew crank out to make the most money? This is what companies would want to know. All right, so let's go through it. So first thing we need to do is write equations that fit these situations. So how about I do, the best way to start, we're talking about chainsaws and wood chippers, is just to put those right across the top. That's the wrong letter. Chainsaws and wood chippers. I'll just do C and W. Chainsaws and wood chippers. Okay. And so first off, we have the hours. It's 3 hours. I'll make a little table, basically, is what I'm going to do. Hours and then profit. So chainsaws take 3 hours. Wood chippers take 5. And over here, the total, or the max, if you want, is, 45. And chainsaws profit $150, wood chippers $220. And you wanna make maximum profit, huh? I'll just write max or whatever. Does that make sense, that little table? So when you're making these tables, let me say this part again, Claire, because I just said it quick and it needs to be said with more emphasis. Take the 2 things they're asking you for. Sometimes it's 3 things. Well, in this section, it'll always be 2 things. The 2 things they're asking you for, and put those across the top. Don't put those down the side, in other words. You could, but this will just be easier for making our equations. So if you just take the 2 things they're asking for, chainsaws and wood chippers, and put those across the top, not down the side, put the other stuff down the side, it'll be real easy and natural to go from there to your equations. How so? What am I talking about? Well, the first equation is 3C plus 5W is less than or equal to 45. Let's see that's true and makes sense. Every chipper that they produce. Oh, that's not a chipper. I mixed up letters. That's a chainsaw, isn't it? That's a chainsaw. Every chainsaw takes 3 hours of assembly. So however many chainsaws they're going to produce, like they're going to make 10 chainsaws, then 3 hours of assembly, that'd be 3 times 10, 30 hours of assembly required, right? So however many chainsaws times 3 hours each, plus however many wood chippers times 5 hours each, has to be less than or equal to 40. Why less than? Because that's the max. The most they can do is 45. They can do only 40 hours. That's okay. You can have your crew only work 40 hours. But the most they have in a week, I guess, to commit to this is 45 hours. So it's less than or equal to. When something's a maximum, you're less than the maximum, right? Okay, now, the other one is the profit equation, which is 150C, because it's in the C column, right? 150C, 220W. And now, what does that equal? Well, you want to maximize that. It's not equal to any number in particular. You want to make it as big as possible. You want to maximize. That's our objective function. Remember how all the problems in last night's homework, they had an objective function? Something that was your goal, your objective. That's my objective function. So in other words, here's the actual, it's like somebody gave me that actual problem. I want to maximize this subject to this constraint. And of course, one other thing that kind of goes without saying, but I'll say it anyway. C, I don't know where to write it. C and W have to be greater than or equal to 0. What's that mean? Why does C and W have to be greater than or equal to 0? Yeah, the number, you can't make a negative number of chainsaws or wood chippers. It's got to be greater than or equal to 0. You can make 0 chainsaws if you want and make all wood chippers with your time, or all chainsaws and no wood chippers, but you can't make negative, right? So when I say greater than, when I say the C and the W in the end have to be greater than or equal to 0, I'm saying it can't be negative, it can't be less than 0. Less than 0 would be negative, right? That'd be so. Now math will go there, so we have to say math, don't go there, right? Math doesn't know about the real world in which we live. It doesn't know you can't make negative chainsaws, right? So it might go there for the best profit, but we have to tell it, no, that's not real life. All right, so now how do we solve? So there's our deal. How do we solve it? Remember, it's all about the graph, huh? We put, do you realize that this one's going to be graph? Let me make note of this one we're going to put on the graph, and this one we're going to plug in at the end. Does that make sense? So the first one, this one, is going to go on the graph, and the maximum one, the profit one, that's where we plug the corners in. We plug in the corners. Remember how we plug in the corners to find which corner is the biggest? That's what we'll put into the profit function at the end of the problem. So let me make sure you get the idea. These are always the same. There's always one function that you plug in at the end of the problem for maximizing profit or minimizing cost. And then there's the other functions that you put on the graph. Okay, so let's put it on the graph. I'm just going to put first quadrant. Why am I only putting a graph with the upper right-hand corner of the first quadrant? Because C and W have to be greater than or equal to 0. I'm going to put C on the x-axis and W on the y. They're my x and my y. You can reverse it. There's nothing magical. Either way is fine. You can put W on the bottom and C on the left if you want. It doesn't matter. Just let one of them be the x-axis and one of them be the y-axis. And then I want to put this on the graph. Go ahead and we'll just use our graphic. In fact, I'm going to go to a fresh screen. Everybody got that copy down? I'm going to go to a fresh screen. What is that? 3C plus 5W, 45. So 3C plus 5W less than or equal to 45. And the profit is equal to 150C plus 220W to maximize. Okay. Okay, so anyway, so when I go to my graph, my C and W graph, if I'm going to do this on my graphing calculator, which might be an easy way to go, remember when you enter the graphing calculator, it's y1 equals, right? So you got to get y alone, huh? Well, who's y? Yeah, I made W be y just because I put it on the y-axis. And you could totally reverse that and it would work fine as well. But I happened to put the W on the y-axis. So that means when it comes to this equation, if I want to graph it, I got to solve for what? W. Because W is playing the role of y. Does that make sense? You could have reversed it. It would have been fine. But since I put W on the y-axis, then W's like y, and I've got to get W alone, right? Because in the graphing calculator, you got to get y alone, so that would be W. So get W alone. So I'd take the little equation 3C plus 5W less than or equal to 45. Jump the 3C over there. I'm going to You can put it in the front or the back, it doesn't really matter, I'll put it in the back. Minus 3c divided by 5. What is that? W less or equal to 9 minus 3/5 c. Everybody okay with that? 45 divided by 5 is 9. So type that into your graphing calculator. Put in y1 equals 9 minus 3/5 x. Just use the x. We won't use c. We'll just know that x is c and y is w. And so type those in to the graphing calculator, your y1 screen. Is it 9 minus 3/5 x? Good? Everybody get that in there? 9 minus 3/5 x. Window, what should you do with your window? Your window should be 0 to 10, 0 to 10 again.
I need to work on the shape both points.
What's that?
Where they meet the x and y axis, I need to figure each in 10.
Oh, did you? Okay, yeah, maybe, yeah. I probably will too then. Let me hit graph and see what I see. Oh yeah, it looks like it's going off the screen. So it looks like I need to go a little further on the x, huh? Everybody seeing that? So yeah, so I'm going to go back and make the x go further to the right. So I'm going to go, okay, 0, how about I just go 0 to 20, or x, huh? X, so 0, 20, right? I need to go further to the right, make the x bigger. 0, 20, yeah, good. Boom. So we good there? Is that making sense? Everybody see how I'm getting that graph on the screen? So I get a graph, so I go 0 to 20 on my graphing calculator. I go 0 to 20 and 0 to 10, and the graph, how far does it go? I don't know, something kind of like this or something. We get a graph on that. Okay, so now we have to find, and which side of that is shaded? Which side of that line is shaded? Look right here. What does it say? Y is what? Or W is less. So shade the lesser, which means in here. So this is the feasible set, is my point, right? The shaded region called the feasible set. In other words, everything in here are real life options the company could go with, right? Anything in this area is a number of chainsaws and a number of wood chippers that the company could crank out. It's possible for them. Does that make sense? These are a bunch of points. Like I could go, well, here, when we get the other points, I'll get more real at the end. Let's save it. So we got to find this point, and we got to find this point, and this, of course, is 0, 0. Remember what you do now? You take the corners of the feasible set. So this will be good review in case you missed last time. This is the same thing again. Once you've got the graph, you just need to check the corners, those 3 corners of that shaded chunk called the feasible region. So 0, 0, you don't need to bother checking 0, 0. That's not going to be the answer. It's going to be either this corner or that corner that's the best answer, maximum profit. First off, I got to find what those corners are. How do I find those 2 points? What's that?
The table for the y-axis?
Yeah, let's go. We can go to the table. Yeah, so for this one, you go to the table and on your calculator, go on your calculator, hit second calc, and then hit table, and look next to x0, right? Because why? Because this point right here is over 0 up something, isn't it? Everybody making sense out of that? That point is over 0. Let me get this out of the way. That point is over 0 up some amount, huh? So everybody okay with the window? I graphed the window. Let me make sure you guys have the right window on your graphing calculator. It's x0, x min, x max is 0 to 10, and y is, x is 0 to 20, and y is 0 to 10. on the window. Okay, anyway, so I gotta find this point. So go to table on your graphing calculator. Hit second. See where table is? Above the graph key. See table up there in the blue? Hit second table. And see what's right next to x is 0? What's right next to x is 0 is 9, huh? Everybody see how I did that? Hit second table. Okay. Coming back here. That means this is over 0, up 9. Good? Now, how do I find this point? Well, this point is over something up 0, isn't it? This one's up 0. This dot right here, it's over some amount up 0. How do I find it?
On the table,
Uh-huh.
can't you just keep scrolling down until
Good.
it is 0?
Let's talk about some other options. There's a couple of things that are probably going to be way easier than the formal 0 method I gave you last time, which will always work. I wanted to give you a surefire thing that'll always work. But yeah, in a lot of cases, let's go back to the calculator. You are totally right. It's going to be easier to just go down the table because we're looking for a y value 0, remember? So let's go down and see where there's a y. See how the y values are going down? There it is, right here. 15 is next to 0, isn't it? See that on the table? 15, 0. That must be that point. So I just went down my table. So coming back to my graph then, this must be the point over 15 up 0. Do you see how we found that? On the graphing, so it's all about the graphing calculator, graphing that line, and then just going down the table. Because I knew this point was up 0, and I knew this point was over 0. Right, everybody seeing that? This dot, this first dot is over 0, up something. This is over something, turns out 15, up 0. Right, so just use the table. Questions I can answer on that? We're almost done with this problem now. That's virtually the end. Let me go back one more time. So everybody doing this on your calculator? I hope you're following along with me on the calculator. Put in the y equals 9 minus 3/5 x, right? That was our function. We took the original function and we solved for w, because w is like y. And I got 9 minus 3/5 c, but I just made that x. 9 minus 3/5 x. Put that in for y1. Right? And then the window. The other thing is the window. Make sure your window is 0.20, 0.10. My x window is 0.20 for min max and 0.10 for y min y max. On that, yeah.
For the y SCO scale, I'm guessing mine is at 0.1, so you just want that at 1 the whole time?
Doesn't matter at all.
Doesn't matter at all?
Doesn't matter at all. Yeah.
So it won't affect anything?
It won't. It's how the dots go on the bottom. We're not even looking at those dots.
Oh, okay.
Yeah, if it bugs you, make it 1, but it won't change
It
anything.
could be
with
like 60.
It totally could.
Okay.
Yeah. It's just how often it's going to put marks on the bottom of the axis. That's what the scale means. That's all it's going to
So
do.
it's going to go by 1 if I'm going to...
If you do ones, if you put a 1 there, exactly. That's right. So everybody got that in, and then hit graph. Yeah.
Did you end up giving the updates for the calculators? Because I wasn't here on Tuesday.
Given the there's a couple things we're doing. You mean the program thing?
Yeah.
Yeah, that I'll do again today. I did some of that after class, but I'll do that today. That's not for this. That's for the next section. But yeah, I will still do that. Yeah, today. But and then we hit graph. You guys getting that graph on your thing? And then yeah.
Whenever I push second table, table, all that stuff, that's not even like.
He doesn't have the Y, he just has the X.
Wow. I'll come by and look in a bit. Maybe the calculator just needs to be reset.
That was happening in mine. So you go to second table setup, and then...
Oh, what do you do here? I'll try to do it up here. You hit. Where's table setup?
right above window.
Oh, I see. Which means table setup. Okay, what do you do there?
It was doing the same thing. I put the table start just at 0. That's all I did. And then,
Table start at 0?
yeah.
That's nice. I like that. And yeah, table start at 0.
And then I went back to...
Do you have options like me
Yeah, I
now?
have that right there. Yeah.
Okay.
So I put
And
that
hit enter. Oh, what else? The delta. That means the change. That means how much it's going to go up by every time. That little delta is a Greek D. It means whenever you see that something, it means difference in. stands for the D in the word difference. That delta is a Greek D. They use that in math science all the time, that delta. It means difference. Difference in table, it means how much are you going up by every time. So start at 0, go up by 1 every time is what that's saying.
Yeah, and then after that, I just went back to the table, and I got...
Just hit enter.
Yeah, I had X,
Enter.
but it went from X, only X to Y1. I have X, Y1, and then I have Y0 now.
Is that working now?
Yeah, I got it.
Good, thanks. So now I made mine start at 0 as well. So you guys have the table set up okay? If you need to change that, let me know. I can come by and help. So now, but now I can't find the, there it is. There's 15.0, yeah. So you see how we get both the values in our table. The 0, 9, and the 15.0. Right off the table. And so we've got those two spots on our graph right there, 0, 9 and 15.0, those two dots. Now we're ready to wrap this problem up. The last thing we do to finish this up is we've got to we've got to plug into the objective function, meaning the answer is either going to be this one or this one. It's always going to be one of the corners of the feasible region. How do you know which one? Well, what's the objective? What is our goal, our objective? It's this. We're trying to maximize that profit, huh? So maximize, what is it? 150C plus 220W. So plug in the 2 points. Now remember, our X is C and our Y is W, right? This is supposed to say W up here, which is playing the role of Y. So, okay, so that means when I do the first point, like the 0, 9, you plug the 0 in for the C and the 9 in for the W and see what you get. So that's just really 9 times 220, huh? Is that 1980? That's right? Okay, thanks. 1980, can you read that up there okay? Boy, it's hard to read that. 1980. And then I'll plug the other one in, the 15.0. So plug in the 15.0, 15 in for the C, the 0 in for the W. And what do we get? 2250. Is that right? 2250. Can you guys read that up there? I could go to a fresh screen on that. Here. So we're plugging into the objective function, which was 150C plus 220W. And we're plugging in the first point, which was 0, 9, and then 15.0. So 0, 9, and 15. You just check the two corners, plug them in, 0 for the first one, 9 for the second one, and then 15 for the first one, 0 for the second, and I got 1980 and 2250.
Why are we using 15.0 for the second?
Because right here. So we're grabbing those 2 points. So we're taking those 2 corner points, 0, 9 and 15.0. That's why we spent all that time finding those 2 points. Because those are the 2 corners. Those are corners, right? Notice we don't use the middle of the line or anything else. We just use the jagged corners, don't we? It's always going to be, you can mathematically prove, we're not going to, we're just going to take the results of the proof that somebody did, that the best answer is always at one of the jagged corners. So we just check the jagged corners. And so 0, 9, and 15.0, plug them in, and there's the 2 answers. So which one's maximum? Which one's best? 2250 is higher than 1980. So 15.0. So what does that mean? 15 is what? And 0 is what? Yeah, chainsaws and wood chippers. They should produce 15 chainsaws and not a single wood chipper. And that'll make them $2,250 in profit, which is better than if they produced 0 chainsaws and 9 wood chippers and only made $1,980 in profit. That's the way to maximize their profit given the limiting constraint of the number of assembly hours they have. That's the best answer for the company there. Does that make sense? How we solve that? Questions I can answer. So we would just type in 0 here. No, 15, huh? 15 chainsaws and no wood chippers. let's go back. Will appreciate because it'll be easier for you. If you're comfortable, yeah. Let me go back to what was our first equation? 3c. This one right here. 3c plus 5w less than or equal to 45. So yeah. Let me just redo it here. From the beginning, we had 3c plus 5w less than or equal to 45, and we were looking to find the points. Right? Here's a quick way. If you're comfortable with math and numbers and stuff, and you want just a really quick way to find these 2 points, that we were looking for, instead of even using the calculator. If you think about it, those 2 points both have a 0, right? Remember, this one is over 0 up something, and this one is over something up 0. A quick way is you can just plug 0 into the formula. If you plug 0 in for C, that's gone. 5 times what is 45? Don't worry about the last time. We're just doing equals right now. 5 times what is 45? 9. That's why when C is 0, W's got to be 9. Right? That's quick, right? And then redo it. Redo it for the other one. If you put, remember, it's C and W, right? Because X and Y, C and W. If you put 0 in for W, 0 in for W, he's gone. 3 times what is 45? 15. Boom, we got our 2 points. No calculator needed. Now, there's other times where we will need the calculator, especially when there's more than one line. But if there's just one like that, that might save you some time. Just real quickly, get your points that way. All right, let's go to a new problem. Here we go. Deluxe coffee is to be mixed with regular coffee to make at least 57 pounds of a blended coffee. The mixture must contain at least 13 pounds of deluxe coffee. Deluxe coffee costs $6 per pound, and regular coffee is $5 per pound. How many pounds of each kind of coffee should be used to minimize costs? To minimize costs. Okay. So let you begin to write the equations. They're telling you the 2 things they want, right? How about we use letters, instead of X and Y, I think it's helpful to use meaningful letters. How about D for deluxe and R for regular? How about we use D and R? So see if you can write a couple of equations. Well, Matt, I'll give you a minute. I'll go around and see if I can help. Yeah, so we're going to do, what are the 2 things? Deluxe and regular, right? So we're going to go, okay, so we have deluxe and regular. And then what does it say about deluxe? The mixture must contain at least 13 pounds of deluxe. And that's it. That's kind of weird. So they put a 13 here. And then that's at least. And then they say deluxe coffee is $6 per pound. Regular is $5 per pound. That's the cost. And you want to minimize the cost, right? We good to there? What do you do with that weird sentence? The mixture must, the one I've got underlined up there, the mixture must contain at least 13 pounds of deluxe. Deluxe must be greater than or equal to 11, huh? I mean 13. Why never 11? 13.
Mine is 11.
Oh, I was thinking of yours, yeah. So 13. That's what that means. So it's weird. It only has to do with the D. There's nothing about the R in that one at all, huh? But then this one, the second one, the cost one, we're trying to minimize 6D plus 5R, aren't we? Remember how there's always one function that's called our objective function, which we're trying to maximize or minimize, that we use at the end and plug the corners into. So this one's for graphing, and this one is for plugging. Plug in at the end, right? That makes sense? You always have 1 or 2 or sometimes 3 that are for graphing, and 1, always just 1, for plugging in at the end. And how you know which one you're supposed to plug in at the end? It's the one they say minimize or maximize. Yeah, let me give you that tip. So whichever one they say minimize, so what do they say? Blah, 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 blah. How many pounds to minimize cost? Minimize cost. Well, right here, coffee costs. Deluxe coffee costs 6, and regular coffee costs 5. So that's how you know that's the end one, right? So the one they say to maximize or minimize, that's the one you use at the end. You don't graph it. You just plug into it at the end. It's the one they say maximize or minimize. They said minimize cost, and then they said cost is $6 and $5. So I go, oh, the one with the 6 and the 5, that's the one I do at the end. I plug into at the end. I don't graph that one. I just graph the other one, the D greater than or equal to 13. Okay, so our whole graph then, if I can erase some of this stuff and squeeze it in over here, our whole graph then is just D greater than or equal to 13. So I'm going to make a graph. Again, first quadrant, because again, D and R have to be greater than or equal to 0. Oh, did I forget something? Oh, I did forget something. Okay. Yeah, let's go back. I'm totally messing up. I didn't notice that. Let's try it again. Deluxe, regular, so we had the 13. Yeah, the other one is 57 pounds. To make at least 57 pounds of coffee. Yeah, what is that equation going to be? I'm trying to make a table out of this. It's not making a table nice. I'm just going to, are you okay if I just say that just means D plus R is greater than or equal to 57? Right? Because the number of deluxe pounds plus the number of regular pounds must be 57 or more if they need to make at least 57 pounds. Does that make sense?
So there's 3 equations?
There's 2 equations for graphing and always just 1 for plugging in at the end. Yeah, so the one that you're maximizing or minimizing, that's always the one at the end for plugging into that's not graphed. So all the rest are always graphed. Yeah, so we have 2 to put on our graph this time, don't we? Does that make sense how I wrote those 2 for graphing? Right? At least 57 pounds of blended coffee. So the amount of deluxe plus regular is 57 or more. Greater than or equal to 57, and deluxe is greater than or equal to 13. So with that in mind, we're going to go to a graph, put deluxe, put regular, first quadrant, graph them. So I'm going to scoot over, fresh screen here. Okay, so we had so when you go to graph, on your graphing calculator, graphing, you got to take the D plus R greater than or equal to 57. And which letter am I going to solve for?
R.
The R, because the R is the Y, huh? So solve for R. So move the D over. So R is going to be 57 minus D. So type that into your calculator. Y1 equals 57 minus X. Type into your graphing calculator. Does that make sense? And graph it. And you're going to find that it doesn't show up in the window very much. Right? You guys getting that? Go to the graphing calculator. Are we getting that? 57 minus X in for Y1. Everybody got that? And then you hit graph, and I see nothing. So what do you do when you see nothing or something crazy on your graph? Change your window. And how do you know how to change your window? Table. Go to the table. Hit second table. And it'll show you the numbers. You go, look at that. Look at those Y values. Those are in the 40s. No wonder I'm not seeing anything. I'm looking at a window that only goes up to 10, and the graph's like, I'm way up here in the 40s. You see why my window's seeing nothing? So I've got to make my window cover those values, be bigger than. So what should I make my Y? Yeah, go up to 50 or 60 or something. Go to 100 if you want to. Right, just something bigger than 46. Something clearly bigger, right? Does that make sense? That's Y max. We're talking about Y max. Right? Those are Y values. That's the maximum Y value. So go back to Y max and make Y max like 50 now. So I'm going to go back to my hit window. There's my Y. X max is 20. That's fine. Y max I'm going to put like 50. Or maybe I should let me just do 100. I'm just going to do 100. Always more is better. Hit 100. Hit graph again. Okay, I'm getting part of something. I'd like to see where it hits all the way to the right, so I'm going to have to make my X go further also. So now go back to window and make X go to like 60, yeah. Or you can do 0, 100, 0, 100. If you want. Maybe I'll do that. Maybe I'll go 0, 100, 0, 100. It doesn't matter. As long as you can see the whole thing. So and by whole thing, I mean you got to be able to see where it hits both axes. Any of those are fine. So I went 0 to 100 for X, 0 to 100 for Y, and I got a graph on the screen. But you could just do 60. That would work fine as well for both. So I did Y max 100, X max 100. And so I got a graph like that. That good? Now, that's this line. How do I graph the other one? Can I use my calculator? What? The D is really what? X or Y? The D is X. My calculator has Y1 equals. It doesn't have X. I cannot use my calculator to graph that D greater than or equal to 13. Does everybody see that? Because D is X. And my calculator only has Y. There's no Y in this equation. There's no Y. There's only an X, huh? D is X. There's only an X. So I can't solve for Y and plug it into my calculator because there is no Y. There's no R. There's no Y. Everybody see that? So I'm just going to have to do it by hand. Just go to D, 13. That's easy. Just go on the D axis and find 13. It might help. It might help to know what this number is and what this number is. You know what they are? Remember how I told you to do it real quick? Look at the equation. They're this equation, right? If you put 0 in for D, what's R? So D plus R is 57. If D is 0, what does R have to be to make that true? 57. 0 plus 57 equals 57. Do you understand what I'm saying? Remember, these always have one of them is a 0, right? Remember the 2 points that hit, if you hit an axis, if you're hitting an axis, one of your coordinates is 0. That's what it means. You're either up 0 or you're over 0, right? Right, the one up here is over 0. The one here is up 0, isn't it? So what? So that means if one of your numbers is 0, what's your other number to make it equal? 57. Or if this one is 0, what's the other number to make it equal 57? 57. Those are both hitting at 57, aren't they? Does that make sense? And you could find that on your graphing calculator table also. If you look through your table, you would find 0, 57, and 57, 0. Now, where's D13? Well, this is the D axis. So where's 13? About right here. There's D13. And I got to make a line, so there's the line at D13. That's the D greater than or equal to 13 line. Everybody seeing that? Right? I just said, look, it says on the D axis hit 13. So on the D axis hit 13, which is not up to 57, right? It's before, it's right here, 13. And I just made a line. It's got to be a line though, not just a point. It's a line that hits the D axis at 13. right? So there's the two lines on the graph. Now where's the shading? Both shadings are greater, aren't they? Both shadings are greater. So I'm supposed to shade greater than this one to the right. Or greater means to the right, huh? And then greater than this one. So where do both shadings overlap? All this region out there, huh? Right? So you with me? So I'm going to erase this so we're clear. And erase this little bit of shading there so we're clear. That this out here, get rid of that. So this out here is the feasible region, isn't it? All out here. Right? We good? That's the feasible region. Everybody okay with that? Everybody see how I'm finding the feasible region? So I've got to find the corners of that feasible region. What are the corners? Well, this one and this one. Not that guy right there, huh? He's not even in the shaded region anymore. He's out. He's not feasible. He's not possible. Why not? Because D has to be 13 or more, and his D is only 0. He's not allowable. That's why he's out. Anyway, we don't have to check all that. So anyway, so here's the only two corners in the feasible region, right? Those are the only two jagged points in the shaded set. You guys with me? Basically, you see the way the shading goes? On these questions, either the shading is going to be below all the lines, or it's going to be outside of all the lines. Always. Always on these. So, and there's an easy way to tell, by the way. Anytime they say minimize, the shading is going to go out, 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 and you want to find the lowest point. See, the shading goes to the right forever. So minimize problem. And then maximize, it's vice versa. Maximize, the shading is going to be down, and they want you to find the highest point. It's always going to be that way. The minimum shading, maximum shading are always opposites. All right, so anyway, so I got to take those 2 points and find which one of those two jagged corners is the minimum cost. Will cost us the least in coffee blending. So how do I do it? Well, I got to find this point here first off, don't I? How am I going to find that point? Do you know either one of his coordinates? Let me draw an arrow here. Does anybody know how far over is he, or how far up is he?
13 over 40.
Yeah, his D is 13. Huh. His D, right? He's at the D13 line. D13, his X value is 13. Does that make sense? His D has got to be 13. Go to the table would be one good way. Or take the D plus R is 57 and put in 13 for D. And solve for R. Subtract 13. R is 44, right? 44? So 44 is D, R, 1344. Yeah, or go to the table. Look at the table on your calculator. Find the D13 and 44 is next to it, right? Is that good how we're finding that? So we've got those two corners. Now we just plug those into the objective function, see which one's lower. We actually want the lower one this time. We're minimizing. Is that okay? I'm going to flash two new screens. Everybody got that copy down? Or maybe I'll just erase what I got here. Yeah, let's just do that. I'm just going to erase, go over here, and I'm going to finish up with the objective function. So what's the objective function? I forgot already. What is it? Deluxe coffee is $6 per pound. Regular is $5. So I'm trying to minimize 6D plus 5R, right? So 6D plus 5. So I'm going to first off do the 1344. So that'd be 6 times 13 plus 5 times 44, which equals, I have no idea. Somebody got that one? 398? 298? 298. Anybody else getting that number?
Yeah.
Okay, good, thank you. And then we'll check the other one, which is what, 57.0? 57, comma 0. And I'll plug that one in. So 6 times 57 plus 5 times 0, 342. Huh. So which one is lower? Which one has a minimum? 298, which means the 1344 is our answer. Does that make sense, what we did there? So let's run over the whole thing again. So they gave me two inequalities, right? They told me D plus R is with 57, so I graphed that line on my graphing calculator. And then they told me D greater than or equal to 13. That meant the line that hits the D axis at 13. Both the shadings were greater. Greater means out, right? So I shaded out, and then I said, oh, okay, here's the two corners of the shaded region, the feasible region. I already had one of their coordinates at 57.0. The other one I found by plugging D as 13 into the D plus R equals 57. Or look on my table, D equals 13. And I found R was 44. So I took those 2 points now, 1344 and 57.0, plug them into what we're trying to minimize. You always end with what you're trying to minimize or maximize. So I plugged them into the minimization, what's called the objective function. Plugged them in, got two answers. In this case, I'm taking the lower one. Last problem, we did a maximum, huh? So I took the higher one. I wanted to maximize profit. This one, I'm trying to minimize cost. 298, that's the lowest cost. So what this company should do, if they want to save the most money, have the cheapest coffee they can, that's still a faithful blend, is they would have 13 of the deluxe and 44 of the regular pounds mixed together to make 57 pounds of the coffee that'll be as cheap as possible. Make sense? Questions? All right, so that's... Okay, so they're giving me the setup. So it's all about, on this question, it's all about how many units of A and how many units of B. So let me write A and B across the top. I'll try that table thing again. Sometimes that will work, I think. So I'm going to put the A and the B across the top. That's the two things they're asking me for, right? So always look at the two things they want, the boxes they have there. A, B. How many units of policy A and how many units of policy B? And then what do they say about those? Well, they say the company needs at least $450,000 fire and theft, I guess. Fire and theft. So over here, oh, they've already got the table for me, don't I? I can just use their table. They got it ready to go. This has to be greater than or equal to 450,000, doesn't it? The fire and theft, greater than or equal to 450,000, and at least, that also means greater than or equal to, doesn't it? Right? At least means that or more, right? At least 5,400,000 liability. Good. All right, now so those are the first two equations. Everybody good with those first two? Let me write those out. So that means 10,000 A plus 15,000. You always stick a plus sign in the middle. We're adding them up. Greater than or equal to 450,000. The second one is 180,000 A plus 120,000 B. Greater than or equal to 5,400,000. Now, what are we trying to maximize or minimize? That's always our objective, right? That one's not graphed. It's used at the end to plug the corners into. Which one is that? These two must be graphing because they're not maximize or minimize. We're going to graph those two. But what's the other equation we're trying to maximize or minimize? Where do they ever say the word maximum or minimum? Minimum premium. Premium. Where do I get that? Premium. So I want to minimize 50A plus 40b. See how I came up with that? There's always one thing you're trying to maximize or minimize. It says minimum premium. So look for that word, maximum or minimum. And in this case, it's premium, and it's 50 and 40. And we're not going to do anything with that to the very end. We're going to plug the corners into that and just pick the lowest one, because it said minimum, they want the lowest. But we're going to graph these two. So it's going to be two lines graphed on our axis system. And is the shading going to be out to the right or down low? Out, maximum, greater, out you go, right? Up and away. So, okay, so let's do that. Let me go to a fresh screen there. We're going to need to clean up. I'm going to get rid of all those extra zeros because they're just a big pain. So let's do that. In fact, I think I can do that right here. You see what we can do, guys, just to make this not so painful? Cut out 3 zeros, cut out 3 zeros, cut out 3 zeros. I just divided through by 1,000. Right? Dividing by 1,000 cuts out 3 zeros. So we have 10a plus 15b greater than or equal to 450. Much nicer. Much more user-friendly. Second equation, same thing. Cut out 3 zeros, cut out 3 zeros, cut out 3 zeros. 180a plus 120b greater than or equal to 5,400. I divided through by 1,000 again. Now, I'm not going to do anything like that with the minimum. That one's at the end. Good so far? Hey, I can actually cut out another zero on that bottom. Let's cut out 4 zeros. 4 zeros, 4 zeros. Let's make this even better, the second one. Hey, we're making it nice here. This is happy. Yeah, there we go. That's better, huh? And we can make him even, I'm getting obsessed with this now, but it's nice. We can make him even simpler. What else could we divide through that top equation by? Well, yeah, the top one by 5. Divide by 5, it'd be 2a. So divide by 5, divide by 5, divide by 5. That'd be 2a plus 3b, and what's that, 90? And what can we divide the second one by? 6, right? That'd be 3a plus 2b greater than or equal to 90. That's better. I'd rather graph these. See what I did there? So I just kept reducing them as far as I could. So those are the two we're going to put on our graph now. So you're going to take both those, type into your calculator. What are you going to solve for? B. Solve for B. And by the way, since we're just going to the calculator, you didn't need to do all that reducing. You could have just typed the whole thing in your calculator. It can do it. You know, as long as you solve for B, it's still probably easier to do it this way. All right, so solve for B, because B is y. We always solve for y. The calculator has y1 equals, right? So we have 2a plus 3b greater than or equal to 90. A plus 2b. Okay, so calculator, so grab the 2a, jump it over, solving for b. We're always solving for the second letter, aren't we? Because on our graphing calculator, we put in y1 equals the second letter, y, not x. So what do we got? 90 minus 2a, divide through by 3. And so that's b greater than or equal to 30 minus 2/3 a. So there's the first one. Solve for b in the second one, jump it over. And there's that one. So this is y1, this will be y2. Type them into your calculator, graph them, So we got y1, we got y2. So type those in and see what you can see. Right, so y1 is 30 minus 2/3 x, and y2 is 45 minus 3/2 x. So type those in, hit the graph button. So if you can, go ahead and type those in. I think it's useful to actually do this and see what you get. Is it working for the TI-92 people? You guys getting it on the TI-92? Derek, right? You get? It's no?
89?
Oh, 89. Yeah, 89.
Yeah, that's fine.
Is it working? You can graph them, you can find them and everything?
Yeah, that's fine.
Okay, good. All right, so type those in. Let me go back. What do we have there? So, yeah. So B, so y1 is, B is greater than or equal to 30 minus 2/3 a. Minus 2/3 a, and B greater than 45 minus 3/2 a. Yeah, so we got that. We go to the graph, A down here, B up there. So what I got when I typed them in, so I got a graph like this. My window's still 0 to 100, 0 to 100. You could change it. It's good enough for me. I'm seeing a graph. You know, I don't really care. So I'm seeing something that comes down like this and something that goes a little further like that. So my window is 0 to 100, 0 to 100. But any window's fine as long as you can see it. All right, now where's the everybody good to there so far? I don't want to mess around too long with the shading. Let's just make this easy because it's the same every time. Is the shading, again, is the shading on this one out or is it in? Out. So it's all out here. It's the outermost reach, right? How do we know it's out? Because they're both greater. Greater means out, right? So here's a corner, here's a corner, here's a corner. Those are the three jagged parts of the shaded piece. The corners of the feasible set. Does everybody see that? Those three corners? Right, because it was greater, so the shading is out. Grab the three corners. So we got to find those 3 points. We got to find those 3 points. How do we do it? Well, to find the one in the middle, you can just do intersection on your calculator. Remember, second calc, choose intersection, and then just hit enter 3 times, and it'll find it. Enter, enter, enter. Right, hit second, calc, enter, enter, enter. And it'll find that intersection point.
18.
Is that what it is? Second calc, intersect, enter, enter, enter. Yes, indeed, 1818. That's what I got as well. This is 1818. You guys getting that on your calculator? Make sure if you have any trouble, grab me, and I'll help you. 1818, second calc, enter, enter, enter. Because that's the intersection. See, because that's the intersection of the 2 lines, isn't it? That's not just a line hitting an axis. Does everybody see the difference? The other 2 corners are where we hit an axis. They're going to have a 0. Right? But the one in the middle is where the 2 lines hit each other. Intersection. So this one is going to be up 0. This one over here is going to be over 0. Remember that whenever you hit an axis, one of your lines is 0. One of your numbers, I mean, one of your coordinates is 0. Question?
For the intersection, when I do enter and enter, it comes up as 18.08, and then y is 17.8, so I'm just rounding.
Check back. Did you enter the fraction or the decimal when you first put in y1 and y2?
Fraction. I put 30
Yeah.
minus 2/3 x, and then.
I can check later. I'm not sure why it's doing that. Yeah, it should be exactly 18.
Okay.
Yeah. So 18, and now for the for these spots, for the 0 thing, how are we going to find those? Well, you got it gets a little more tricky here. You can plug into the equations, or you can use your graphing calculator. Do you remember how to do the 0 thing? That's probably the easiest. Remember how to do the 0 thing on the graphing calculator? Because now it's just a little tricky. You'd have to figure, yeah. So I'm going to go more formal now. Remember, well, let's do this. There's this one. Yeah, you can find this one with the table. Yeah, you can still find the table on this one, right? But there's 2 y values now, aren't there? When you go to the table, you can tell it's the higher one. See how this one hits lower, this one hits higher? I don't know if it's y1 or y2. It depends which order you put the equations in. It's the bigger one, right? When x is 0, find the one that's the higher y value among the 2 in your table. Is that making sense? I'll show you here. I go to second table. So if I go down, yeah, I'm looking. See how these numbers are going? See over here, they're going down?
You need to go up though, because you need x 0.
Oh, yeah, you're right. Thank you. I need x 0. I'm going the wrong way. Let's go to x 0. There we go. Thank you. So x is 0. Which of the y values? One of them hits at 30, the other hits at 45. See that? So just it's whichever order you put it in there. So yeah, so if you go back, that means this one's at 30. This one's at 30, this one's at 45. I need the 0, 45. It's telling me where the 2 lines hit the y-axis, right? And then for the other one, let's go to the second table again. Can you get the other one from the table too?
It's 45. Yeah.
Yeah.
Yeah, if you go down, now we're looking for y values that are 0. Let's go down, down, down. Give me a y value 0. There, okay, there's one of them. One of them's at 10. One of them's at, what is that? 30 0, and the other one is at, still going down for the other 0, 30 0, oh no, there it is, 45 0. 30 0 and 45 0. So that means this must be at 30, this must be at 45, right? This one's at 30, this one's at 45. I need the 45 0. See how I'm finding all that from the table? Everybody getting that? All right. These are the 3 corners. Plug them into your objective function. Let me put my objective function over here. What is my objective function? I forgot now. What were we trying to minimize or maximize? There it is. Minimize 50A plus 40B. Back 2 screens. Here it is. Minimize 50A plus 40B. So minimize 50A plus 40B. So do the first one, 0.45. So the first one, 0.45. 50 times 0 plus 40 times 45 equals some big number. Somebody got that? 1,800? Yep. 1,800. All right, next. We try the 1818, and that's 50 times 18 plus 40 times 18. I have no idea. 1620. Thank you. 1620. That is lower. So far, that's the winner. We're at the minimum, right? And now let's try, what's the last one? 45.0. This one. So 45.0. So 50 times 45. Plus 40 times 0 equals something. 2250, thank you. So the minimum is the 1620, the 1818. That's the plan, the insurance plan. They should go with 18 units of A and 18 of B. That'll be the lowest cost to cover their needs. Does that make sense? Can we squeeze one more in? Questions on that? Let's look if there's anything really weird. We'll stop right there.